Composition of two functions involves putting one function into another one, and there are certain things with the domain that we have to be very careful with when we're making compositions of functions. First is that the final function that's produced by the composition must have the same domain restriction as the inside function, or g of x, and it also will have a final domain restriction based on the final form of f of g of x. So here's an example. It says consider f of x equals x plus 3, g of x equals x squared minus 6. We're going to find g of f of x and state its domain. This is the same as g with f of x inside of it. And this is g of replacing f of x with x plus 3. Now, wherever we see x, we replace with x plus 3 in this function here. So we'll take x plus 3 and square that, minus 6. We could simplify this a little bit. This is x squared plus 6x plus 9 minus 6, and this gives us x squared plus 6x plus 3. So that is the composition function. And if we want to find its domain, we look at the inside function. This has no domain restriction, and this one also has no domain restriction, and because of this, the domain is all real numbers. The second example here, we have two different rational functions, and we're looking for f of g of x. So we're looking for f of plugging in g of x, which is 2x plus 6 over x minus 4. Now, wherever we see the x in the f function here, 3 over replacing x with 2x plus 6 over x minus 4. And this is still minus 3. Now we have to do some algebra in order to simplify this. I'm going to multiply 3 by a fancy form of 1, or x minus 4 over x minus 4. This will give us a common denominator. This is then the same as 3 over 2x plus 6 over x minus 4 minus 3 times x minus 4 all over x minus 4. Have a common denominator, so we can subtract those. This is 3 divided by 2x plus 6 minus 3 times x minus 4 all over x minus 4. I'll simplify a little bit. So 3, this is over 2x plus 6 minus 3x plus 12. Just distributing that out all over x minus 4. I'm going to go back down here and simplify that numerator again. So this is 3 over negative x plus 18. And this is over x minus 4. I can think of this as 3, big 3, divided by negative x plus 18 over x minus 4. And we change this to multiplication, take the reciprocal. And I can write this as 3 times x minus 4 all over negative x plus 18. Now, to determine its domain, we have to look at two different areas. The final composition here, since we have division, we have that negative x plus 18 cannot equal 0. And this is the same as x not being able to be 18. Add x to the other side. So that's one domain restriction. The other one comes from the argument here. We have x minus 4 cannot equal 0. We add 4 to both sides and we get x cannot equal 4. So two domain restrictions, but all the other numbers work, and we can say the domain is from negative infinity to 4, and then from 4 to 18, and from 18 to infinity. So just discluding those two numbers, 4 and 18. For this one, we have two square roots, and we're first looking for h of j of x, and this is h of the square root of 5 minus x. And this is then the giant square root of the square root of 5 minus x minus 3. Okay, and that's as simplified as it gets. We have to be very careful with the domains in this case. So looking at our final composition function here, we have that the square root of 5 minus x minus 3, that's inside the square root, so that must be greater than or equal to 0. I'll add 3 to both sides. I'll then square both sides. And I'll add x to the other side and subtract 9 from both sides. So this is giving me that x is less than or equal to negative 4. For the other domain restriction, this one here, 5 minus x must be greater than or equal to 0. I'll add x to the other side. And this is the same as x is less than 5. But if x is less than negative 4, it's automatically less than 5. And we just take this last one as our domain restriction. We can think of this as the intersection of these two intervals. And that's just where they overlap, and they're overlapping from negative infinity to negative 4. So domain is this. We can include -4 in our domain. Let's look at j of h of x. J of h of x. That's j of h is what? Square root of x minus 3. And we'll plug that into the other function. And that's as simplified as it gets again. So we have to be careful now with the domains. Looking at this one, we have 5 minus the square root of x minus 3. That has to be greater than or equal to 0. I'll add the square root to the other side. And then square both sides. Finally, add 3 to both sides. And we get that x is less than or equal to 28. That's one of our restrictions. The other one comes from here. We have x minus 3 must be greater than or equal to 0. We get x is greater than or equal to 3. And if we take the overlap of these two intervals, this one's shading to the right, this one shades to the left. And the overlap is from 3 to 28. So the domain is from 3 to 28.